A moment so still it swallows all thoughts. Imagine floating in infinite space, alone before the control panel of a ship plunging into the vast darkness, far from all the stars, far from every sound, far from memories of Earth. Before you, a blinking screen. 100,000 kilometers per second, 200,000 kilometers per second, 250,000 kilometers per second. Breath seems to stop, time stretches, reaching the unimaginable, the speed of light. But what really happens if you're sitting in such a spaceship and reach the speed of light? What happens if you try to exceed it? Because this speed is always taught as an absolute limit that cannot be surpassed. We've learned that since middle and high school. We accept that without really questioning or contemplating it, because this limit creates countless problems and many paradoxes. Is there an invisible wall blocking us, or a mysterious force holding us back when trying to exceed the limit? Why can't we go faster than this speed? When falling into space, eventually you reach terminal velocity. Actually, that's the maximum speed that cannot be exceeded, but you can't surpass that speed, because air and friction slow us down. The faster you fall, the more the air pushes back until balance. But in a vacuum, no friction, so what stops us from accelerating indefinitely? This question is extremely important because we are currently discussing a lot about space exploration and travel to other planets. The problem is the speed of light. It is slow and takes a lot of time. On our scale, the speed of light is very fast. We can't see it passing by. We often use the phrase speed of light to refer to something extremely fast, but on a cosmic scale, it's insignificant. Even for the sun, light takes several minutes to reach us. That means if the sun suddenly went dark, we'd only know after 8 minutes due to the travel time of light. Because the speed of light is slow, it takes time. But it's even worse for stars in our galaxy. They take hundreds of thousands of years for their light to reach us. When we observe the stars in the galaxy, we are actually seeing what happened hundreds of thousands of years ago. When we look far into the universe, we are essentially looking into the distant past. Because we cannot exceed the speed of light, traveling from one end of the galaxy to the other takes hundreds of thousands of years. But reaching other galaxies takes an extremely long time, and it is this limit that hinders us on Earth. So in fact, we are talking about something far from trivial. Exploring the mystery of the speed of light can help us better understand the universe we live in, while also opening up interstellar travel. I know you might think, this video is interesting, but we already know the answer. You cannot exceed the speed of light. You'll see that this question is often misunderstood, and the truth, as always in science, is much more subtle. Reaching the speed of light is not impossible. In fact, right now, you are moving at the speed of light without realizing it. Every particle in your body, right now, is moving at the speed of light. But to understand this wonder, first let's rewind time a bit. It all began in Paris in 1676, on the roof of the Royal Observatory. One night, the young 32-year-old Ole Rømer, a Danish astronomer, was diligently observing the sky with tireless perseverance. He was not hunting for comets or grand lunar eclipses, but focused on something much more subtle. What brought even more surprising revelations was the orbital cycle of Io, the fastest moon of Jupiter. His work sounded simple, recording the times when Io was occulted to help sailors navigate at sea. Yet, hidden behind those repeated calculations was a mystery, a small delay, a discrepancy in the eclipses. Rømer discovered that when Earth moved farther from Jupiter on its orbit, the occultations occurred later. And when the two planets drew closer, they arrived slightly earlier than predicted. These discrepancies were subtle but consistent, and in the end, the discrepancy amounted to 22 minutes at the farthest distances. Most astronomers blamed Io's irregular orbit. But Rømer sensed something greater. He had a bold intuition, an idea almost heretical for his century. What if light also took time to travel? Try to imagine that moment. The universe, once thought instantaneous, suddenly changed completely. The sky, the vast stage where all events seemed to occur without delay, turned out to be a delayed performance. Rømer proved it. Rømer understood that when Earth was farther from Jupiter, light had to travel a longer distance. Therefore, it took additional time, and that time caused the delay. With the rudimentary equipment of his time and estimates of Earth's orbit, he estimated the speed of light. The figure he gave was 200,000 kilometers per second. That was the first time, a great leap in humanity's understanding of the universe. For the first time, humans discovered that light. That beam of light, seemingly instantaneous, was not infinite. It had a speed, its own rhythm, but that was only the beginning. Rømer had just revealed an astonishing truth. This truth would soon pose an even deeper question. Could this speed be measured from Earth with unquestionable precision? It was not until 1849, 2 centuries later, that a young French physicist dared to take up the challenge. His name was Hippolyte Fizeau. Fizeau, 29 years old, had an idea both simple and brilliant. Why not measure the speed of light right here on Earth, just like measuring the speed of a horse or a ball? Between 2 cities, he built a device of marvelous mechanical beauty. A light source, a rapidly rotating wheel, and a mirror placed 8 kilometers away. The principle was extremely simple. Light passed through the gaps in the wheel, traveled to the mirror, reflected, and returned. If the wheel rotated fast enough during this 16 kilometers round trip, a moving tooth would block the light beam. By fine-tuning the rotation speed, Fizeau found the exact point when the light disappeared. He then calculated the time needed for this journey. The result was 315,000 kilometers per second, only a few percent off from the modern value, astonishing for a measurement using only mirrors and metal teeth. What is impressive is not only the accuracy of the number, but also the experimental proof that light was not an abstract concept. It obeyed a speed limit that could be measured, observed, and made tangible. Now, it is no longer just a distant idea. It is a physical reality that can be measured, grasped, and understood. But a greater mystery awaits ahead, because in the following years, a new experiment attempted to prove the existence of the invisible medium through which light travels. To everyone's surprise, it failed. That null result shook the foundations of physics. Thus began one of the greatest revolutions in human thought. The time was 1887 in Cleveland. Albert Michelson and Edward Morley, 2 physicists, were about to perform a pivotal and most mysterious experiment in the history of science. Their goal was simply to detect the ether. At the time, everyone believed that light, like all waves, needed a medium to propagate. They imagined an invisible medium, omnipresent and immobile. That was the luminiferous ether. All of space was filled with this ghostly substance, and light oscillated like ocean waves. Theoretically, if Earth were moving through the ether at 30 kilometers per second around the sun, then the speed of light would vary depending on the direction of Earth's motion. Like swimming in a river, downstream is faster, upstream is slower, and swimming across, your path would be deflected. So Michelson built an extremely precise device, an interferometer. This instrument splits a beam of light into 2 and sends them in perpendicular directions. Then they are recombined. If the ether exists and light takes different times for the 2 paths, a shift in the interference fringes would appear, visible to the naked eye. Simple calculations and the predicted result were obvious. There would be a shift of 0.4 fringes, easily measurable. After confirmation and preparation, he conducted the experiment. The result, nothing. No shift, no change. He rotated the device 90 degrees, still nothing. He repeated the experiment in different seasons, hoping to detect an effect from Earth's orbit, but still no change. Light propagated at the same speed in all directions. The result was not only astonishing but also inexplicable. How could that be explained if Earth was hurtling through an ether wind? Like swimming in a swift river, but your swimming speed remains constant no matter which direction you swim. Physicists were bewildered. Some thought Earth might drag the ether along, like the air layer surrounding an airplane. Others were bolder, suggesting that objects shrink gently in the direction of motion. This hypothesis was proposed by George Fitzgerald. It was called length contraction. But these were all conceptual patches to avoid challenging the foundations of Newtonian physics. Then, one day, in a small patent office in Bern, Switzerland, a 6-year-old young man, with messy hair and a knowing smile, he scribbled ideas in his notebook. Albert Einstein had a thought no one had dared before. What if it is not light that adjusts to our motion, but rather time and space themselves are bent to keep light constant? At that time, He worked 6 days a week at the patent office in Bern. While studying how to synchronize clocks for the Swiss railway system, a seemingly simple task, he accidentally stumbled upon the greatest discovery in modern physics. Imagine him grappling with the problem of coordinating time between train stations, how to make every clock across the entire network show the exact same time. How can we define the simultaneity of events that are far apart? Those practical questions nurture deeper reflections. Einstein posed a simple, almost naive question. What would happen if I ran alongside a beam of light? According to classical physics, I would see the light as standing still, like a wave frozen in space. But Maxwell's equations of electromagnetism asserted that this could not happen. An electromagnetic wave cannot stand still. It has no physical meaning at all. This fundamental contradiction led Einstein to question our most basic understanding of reality. And then Einstein made a bold gamble, one of those gambles that changed the course of history. Instead of doubting Maxwell's equations, he challenged all our concepts of space and time. He proposed 2 revolutionary postulates. The first, the laws of physics are the same in all inertial frames of reference. Simply put, there is no preferred frame of reference in the universe. You can never claim to be absolutely at rest. The second postulate, the speed of light in a vacuum is constant for all observers, no matter how fast they are moving. Sounds crazy, right? How can light have the same speed for everyone? That completely contradicts our everyday experience. Let's imagine. You are sitting comfortably on a train traveling at 100 kilometers per hour. In front of you, right in the aisle, you hold a ball. You throw the ball forward at 50 kilometers per hour relative to the train. To a stationary person on the platform watching, the ball moves at 150 kilometers per hour. A very basic principle. It's simple, intuitive, natural velocity addition. Now, let's repeat that scenario. The same train, same motion. But this time, you turn on a flashlight. The light beam shoots forward at 300,000 kilometers per second in your own frame of reference. And to the person on the platform, the speed is exactly the same, precisely the same, not even a km, h faster, nor slower. How can that be? Why doesn't light add up with the train's velocity? Because something invisible, but extremely fundamental, is at work. The elasticity of space-time. Einstein revealed, for light to maintain its nature, time must slow down and space must contract. The universe has its own rules to preserve that invariance. Space and time, which we believe to be absolute and immutable, turn out to be flexible, adaptive, and relative. What Newton saw as a static stage, a fixed cosmic backdrop, became for Einstein a dynamic performer, a silent dancer bending, stretching, or shrinking to the rhythm of motion. Truly an unimaginable revolution. We don't simply move through the universe, we also distort the universe with our very motion. But why that exact speed number? Why 299,792,458 kilometers per second, not even a km, h more? From the very beginning, we made a huge mistake. That speed does not belong only to light. That name is actually a historical misunderstanding, an accident that misled humanity for over a century. Gravitational waves and massless neutrinos also travel at that speed, not just light. In other words, anything without mass is compelled to zoom at that maximum speed. They have no choice. Because they are massless, they cannot slow down or stop. So ultimately, what is this speed really? This speed is the speed of information, of causality, and literally, the speed of reality. Imagine the universe as a giant 4-dimensional elastic grid. That grid has a fundamental property. Information cannot travel faster than a certain threshold. That threshold is approximately 300,000 kilometers per second. Why that exact number? It's like asking why pi is 3.14. Nature didn't arbitrarily set it. It is a fundamental property of space-time geometry, etched into the very fabric of reality. This speed determines the causal structure of the universe. It dictates how cause produces effect, how information spreads, and how the universe maintains consistency and logic. Without this limit, causality disappears, effects could precede causes, and the universe would plunge into incomprehensible chaos. Then past, present, and future would blend into a chaotic mess of time. Therefore, This speed limit is not an arbitrary constraint from a capricious universe. It is the speed at which consistency propagates through space-time, the rhythm at which reality synchronizes with itself. Suppose the sun suddenly extinguishes. We would only know after 8 minutes and 20 seconds. The reason is not that light takes time to reach us, but because information about that event cannot exceed this fundamental speed. During those 8 minutes and 20 seconds, Earth would still be orbiting a sun that no longer exists. The reason is that information about the disappearance of gravity hasn't reached us yet. That is the speed at which the universe updates its own consistency. This is a revelation that will completely overturn your perception of reality. The speed we have just discovered, the universal limit, the speed of cosmic consistency, you have actually experienced it in every moment of existence. So if this speed determines the structure of the universe, dictates how information spreads and how cause produces effect, then what does it say about our own existence? Because we ourselves are also information. We are events spreading across the universe. We are also part of that great symphony of causality, and right then, everything began to change. To understand what I am about to share, you must first completely change your conception of space-time. Eliminate the idea that space and time are separate things. Don't think that one is 3D space and the other is steadily flowing time. In reality, space and time are a single, unified entity. They merge into what is called space-time, a single four-dimensional entity, 3 dimensions of space and 1 of time. Imagine you are looking at a road map. Looking at the map, you'll see roads running north-south and others running east-west. You can choose to go in one direction instead of the other. Whether you choose north or east, you're still moving on the same map. The same happens with space-time. You can move a lot in space or a lot in time, but it's all within the same entity. The core point of space-time is, any motion has a constant total velocity, and that number is the speed of light. You cannot escape that velocity. You can't decrease it. You can't increase it. You are always moving at that speed in space-time. The only thing you can do is redistribute this velocity between space and time. Recall the analogy with a road map. Imagine you have a fixed velocity budget, say 100 kilometers per hour. You can decide to go 100 kilometers per hour north and 0 kilometers per hour east, or 50 kilometers per hour north and 50 kilometers per hour east, or 0 kilometers per hour north and 100 kilometers per hour east. Whatever you choose, the total velocity remains constant. Only the allocation changes, and that is exactly analogous in space-time. You possess a fixed total velocity budget, identical to light's. You can split it between motion in space and motion in time. When you are completely at rest, your entire velocity budget is devoted to the time dimension. You hurtle through time at the speed of light. When you stand up and start walking, you transfer a small part of your time budget to spatial motion. You are slowing down time a little, in quotes, to speed up in space. When you get in a car and drive at 130 kilometers per hour, you allocate more of the budget to space, meaning your time slows down a bit more. If you board a rocket and approach the speed of light, you redistribute. Almost all of your space-time budget will cause time to pass much more slowly compared to an outside observer. That is Einstein's discovery of time dilation. This is not a mysterious effect, but simply the result of reallocating velocity from space to time. But this revelation will change how you see yourself. Even if you believe you are completely still, in reality you have never been truly motionless. Right now, as you sit still, you are still traveling through space-time at the speed of light. You are a cosmic traveler, an explorer of space-time. You have been in constant motion since birth and will continue until you leave this life. Every second of existence, you move nearly at the speed of light along the time dimension in space-time. Photons are the complete opposite. A photon dedicates its entire velocity budget to the space dimension, speeding at 300,000 kilometers per second, but for it, time stands still. A photon from a star billions of light years away does not age even a nanosecond when it reaches your eye. You and that photon travel together with a constant total velocity throughout space-time. The key is how speed is distributed between space and time. Now you see why being completely stationary is impossible. It goes beyond technical limits. Immobility is conceptually impossible. Being stationary means not existing in time. You are frozen in eternity, cut off from the flow of reality. That is equivalent to ceasing to exist. Absolute stillness is the death of all existence. Reality can only exist through eternal motion in space-time. You are condemned to move, forced to carry speed, compelled to dance this cosmic dance until the end of time. The next time you gaze at the stars, remember, you are not standing still to observe. You are observing from your own spaceship, hurtling at the speed of light through space-time. Your fate is to move forward. No choice, no stopping. You cannot go back, nor can you stand still. The universe imposes a constant speed upon you in space-time. Within that condemnation lies a single freedom, to choose your direction. You can focus on moving through time, almost standing still in space. Or you can go further in space by slowing down time. We are cosmic travelers condemned to perpetual motion. Freedom to choose your own path. The speed of light is not a barrier separating us from the stars. It is the inevitable rhythm of existence, the beat to which all must march toward the future.